Welcome to Deep Sleep Physics. I hope you're doing well and that you're ready to find some peace tonight. It's a pleasure to be your guide through the mysteries of the dark. To understand the end, we must first look at the silent, relentless expansion of the fabric of space. Every galaxy, every star, and every atom is part of a vast, unfolding narrative that has been written across billions of years. The universe is not a static place. It is a dynamic, breathing entity that began in a flash of heat and has been cooling ever since. As we look into the furthest reaches of the night sky, we are witnessing the physics of the inevitable. The expansion of the universe is not slowing down. It is accelerating, driven by a mysterious, invisible force known as dark energy. This energy acts like a cosmic wind, pushing the great islands of stars further and further apart, into the cooling, indigo depths of the void. Imagine the sheer scale of this movement, a slow, steady stretching of reality itself, where the distances between the galaxies grow so vast that even light cannot bridge the gap. Eventually, the neighbors of our own Milky Way will drift beyond the cosmic horizon, disappearing from our sight forever, leaving us in a local sanctuary of stars, surrounded by an infinite, empty sea. The physics of the end is a story of thermodynamic destiny, a journey toward a state of perfect, unwavering equilibrium. Heat moves from the hot to the cold, from the burning hearts of stars to the freezing reaches of the vacuum. And in this movement, energy is slowly, quietly spent. There is a profound, ancient peace in this transition, a realization that the universe is moving toward a state of absolute, restful stillness. In the early stages of this long sunset, the universe continues to produce new stars, born from the collapsing clouds of gas and dust in the spiral arms of galaxies. But the supply of hydrogen is finite, and the cosmic nurseries will eventually fall quiet. This era is known as the Stelliferous Age, the age of light. But even light must one day find its conclusion. The stars are like glowing embers in a fireplace that is slowly, very slowly, losing its warmth. There are different theories about how the final chapter will be written. Some speak of the Big Freeze, a state where the temperature of the entire cosmos reaches a fraction above absolute zero. Others speak of the Big Rip, where the acceleration of space becomes so violent that it tears the very atoms apart. And then there is the Big Crunch, a slow, rhythmic collapse back into the singularity from which we came. Each path leads to a different kind of silence, a different kind of peace. Tonight, we explore the science of the long goodbye, looking at the facts of the far future as if they were a soft, fading melody. The stars that we see above us are beautiful, but they are also temporary, part of a flickering, golden moment in the grand timeline of existence. By understanding the end, we find a deeper appreciation for the quiet, steady now. The universe does not rush toward its destiny. It moves with a patience that is beyond human comprehension, thousands of trillion years in the making. Every second, a slow, deliberate step toward the dark. We are traveling through the physics of the far future, where time itself begins to stretch and the light of the stars begins to dim into the perfect velvet blackness of the ultimate rest. The current era of the universe, the age we inhabit, is a fleeting period of brilliance known as the Stelliferous Age, a time defined by the burning of stars and the constant, radiant cycle of stellar birth and death. But this luminous epoch is merely a brief flicker in the vast, unfolding timeline of cosmic history. The universe is a reservoir of potential, a finite collection of hydrogen and helium gas that serves as the fuel for every sun in every galaxy. And as the billions of years slip quietly into the past, that reservoir is slowly, steadily being depleted. Stars are the engines of the cosmos, but even the most massive and powerful among them are subject to the cold, hard laws of thermodynamics. They convert their internal fuel into light and heat, radiating their energy away into the hungry, dark vacuum of space, where it can never be reclaimed. Imagine the long-term history of a galaxy as a slow dimming of a great city's lights. One by one, the most brilliant lamps begin to flicker and go out. The largest stars, those blue giants that burn with a fierce, short-lived intensity, are the first to vanish, leaving behind only the smaller, cooler, and more patient stars to carry the light forward. These are the red dwarfs, small, dim, crimson suns that burn their fuel with incredible, parsimonious efficiency. While a star like our Sun may live for billions of years, a red dwarf can endure for trillions, glowing like a low, steady coal in the dark. This represents a massive shift in the physics of the night sky, as the vibrant blues and whites of the young universe fade into a soft, muted amber. The night becomes deeper, the spaces between the stars grow wider, and the overall temperature of the cosmos continues its slow, inevitable descent toward the freezing point of reality. In this era, the formation of new stars becomes an increasingly rare event. The gas clouds that once birthed thousands of suns become thin, cold, and exhausted, stripped of the materials needed to ignite the fire of fusion. The galaxies themselves begin to change, losing their spiral arms and settling into smooth, featureless, elliptical shapes, like old, tired systems that have finished their work. Gravity, the invisible hand that once pulled the universe together, now works to consolidate what remains, drawing dead stars and cold planets into tighter, darker clusters. This is the physics of the slow fade, a transition where the universe moves away from the chaotic, violent energy of its youth and toward a more stable, quiet, and predictable maturity. There is a profound, heavy stillness in this period of cosmic history, a sense that the frantic activity of life and light is giving way to something much larger and more enduring. Even the heavy elements, the carbon, the iron, and the gold, become locked away in the cold corpses of dead suns, white dwarfs, and neutron stars. These are the remnants of the age of light, celestial artifacts floating in a universe that is becoming increasingly dark and increasingly cold. The background temperature of space, once hot enough to melt stone, has now cooled to a few degrees above absolute zero as the expansion continues to stretch the remaining photons until their energy is a mere whisper. We are witnessing the beginning of the long cooling, the transition from a universe of fire to a universe of ice, where the only movement is the slow, rhythmic orbit of cold spheres in a sea of black velvet. The light is not being extinguished all at once. It is retreating, receding, and finding its final resting place in the deepest, most distant corners of the void. This cosmic cooling is not merely a change in temperature. It is a fundamental shift in the architecture of reality. Inside the hearts of the remaining stars, the process of nuclear fusion is becoming a heavier, more labored, and much more difficult task. The early universe was a garden of pure hydrogen, the simplest and most abundant building block of all things. But as the generations of suns pass, they act as celestial forges, processing that primordial gas into heavier and more complex elements. They forge carbon, neon, oxygen, and finally, iron. Iron is the ultimate ash of nuclear fire, a point of no return where fusion no longer releases energy, but instead consumes it. Imagine the core of a massive star becoming a sphere of solid, unyielding iron, signaling the end of its life and the beginning of a silent, gravitational collapse. Every time a star perishes, it leaves behind a cloud of enriched dust. But this dust is harder to ignite than the pure gases of the beginning. The universe is becoming more complex, but also more tired. The vibrant, energetic blues of the young galaxies are being replaced by the deep, somber reds of aging systems. These red dwarf stars, though small, are the true heroes of the long night. They do not explode in a flash of glory. They simply exist for trillions upon trillions of years, like a slow, steady heartbeat in the dark. Their light is so faint that it would barely be visible from the planets orbiting them, a permanent twilight that never turns into day. In this era, the distances between the stars are also changing. As the expansion of space continues to accelerate, the gravity that once held galaxies together in great clusters begins to lose its grip. The great cosmic web, the structure that connects the universe, is beginning to fray, like an ancient, silken tapestry being pulled apart by invisible hands. Each galaxy is becoming a lonely, isolated island, drifting further and further away from its neighbors until the light from other worlds can no longer reach them. A telescope on a planet in the far future would see only an empty, black sky with no other galaxies in sight. The universe is effectively shrinking into a series of solitary, dark cells. As the last of the red dwarfs finally exhaust their nuclear reserves, flickering out like the final embers of a dying fire, the universe enters a long, cold, and profoundly quiet chapter known as the Degenerate Age. This is a landscape defined by the remnants of what once was, a cosmos populated not by burning suns, but by the dense, cooling corpses of stars. White dwarfs, neutron stars, and black holes become the primary residents of the great, dark galleries of space. Imagine a universe where the light of fusion has been replaced by the faint, ghostly glow of thermal radiation. White dwarfs are the Earth-sized hearts of stars like our Sun. Composed of highly compressed carbon and oxygen, they no longer produce energy. They simply store the heat of their past lives, radiating it away into the void over quadrillions of years. This is the physics of the slow cooling, a world where time stretches beyond human measure, and the temperature of these stellar remnants slowly, steadily sinks toward the absolute cold of the surrounding vacuum. There is an incredible, heavy density to this era, as gravity has crushed matter into its most compact forms. A single teaspoon of a white dwarf's material would weigh as much as a mountain, while the material of a neutron star is so dense that it defies imagination. A city-sized sphere with the mass of a sun spinning in the absolute velvet blackness. These objects are the anchors of the degenerate age, floating in a universe that is now trillions of times larger than the one we know today. The expansion of space has pushed the galaxies so far apart that they are no longer visible to one another. Each galaxy becomes a lonely, isolated island of dark matter and cold cinders. In this era, the very atoms themselves begin to face a slow, inevitable transformation. One of the most profound mysteries of physics is the stability of the proton, the fundamental building block of matter. If protons are unstable, as many theories suggest, then even the solid stone of dead planets and the dense cores of white dwarfs will eventually begin to dissolve. This is not a violent process, but a slow, silent evaporation, where the matter that makes up the mountains, the stars, and the bones of the universe simply turns into light and subatomic particles over a time span so vast that 1 trillion years is but a single heartbeat. Every star, every planet, and every cold, drifting moon becomes a ghost, slowly thinning out into the expanding indigo void. Until that happens, the white dwarfs will eventually cool so much that they become black dwarfs, dark, cold diamonds of crystallized carbon, invisible to any eye. They wander through the dark as the ultimate artifacts of the age of light. The physics of this age is one of profound, unwavering patience. There are no more supernovae, no more nebulae, and no more light to illuminate the dust. Only the slow, rhythmic dance of black holes and cold cinders remains as the universe continues its relentless, icy expansion. The energy of the cosmos is being spread so thin that it becomes a mere whisper, a background hum that is nearly indistinguishable from silence. This is the true maturity of the universe, a state where the frantic energy of youth has been replaced by a deep, permanent, and peaceful stability, where the only thing that grows is the space between the remnants, and the only thing that lasts is the dark. We are drifting through a museum of dead suns, where the halls are infinite, and the silence is a physical weight, moving further away from the warmth of the beginning, and deeper into the eternal iron peace of the end. As the eons stretch into numbers that defy the limits of the human mind, the universe transitions into an era of shadows and gravitational giants. The era of solid matter has passed. The last black dwarfs have dissolved into the void, and the only remaining structures in the vast, thinning cosmos are black holes. These are the titans of the dark, the final concentration of the universe's mass, gathered into points of infinite density. In this age of black holes, the physics of reality becomes a study in extreme patience, a slow, rhythmic process of decay that occurs over timescales so immense they dwarf the entire history of the stars. A black hole is not a permanent tomb, but a vessel that slowly, silently leaks energy back into the vacuum through a process known as Hawking radiation. This is the physics of the Titan's breath, a quantum whisper where the intense gravity near the event horizon causes pairs of particles to manifest from the empty space. One particle is reclaimed by the dark, while the other escapes into the void, carrying with it a tiny, microscopic fraction of the black hole's mass. Imagine the scale of this evaporation. It is a movement so slow that a black hole with the mass of our Sun would take more than a decillion years to vanish, while the supermassive monsters at the centers of galaxies will endure for a duration that makes the current age of the universe seem like a single, fleeting spark. The universe in this period is a place of absolute velvet blackness. There is no starlight, no warmth, and no movement other than the invisible, hawking glow of these dying giants. As a black hole loses mass, it actually begins to grow warmer, its evaporation accelerating as it becomes smaller and smaller, like a candle that burns brighter and faster just before it flickers out. For almost all of its life, the black hole is a cold, silent anchor. But in its final moments, it releases a sudden, brilliant flash of high-energy light, a final, radiant exhale that signals its departure from the fabric of reality. This is the last light the universe will ever see, a brief, sharp goodbye in a cosmos that has otherwise become a desert of shadows. The space between these titans is so vast that light itself takes trillions of years to travel from one to another. Each black hole exists in a state of perfect, total isolation, unaware of any other presence in the expanding indigo void. Dark energy continues to push the boundaries of the universe further apart, stretching the space between the remaining points of mass until the very concept of distance loses its meaning. There is a profound, ancient dignity in this process. The universe is systematically and quietly cleaning away the last remnants of its physical self, returning the borrowed energy of the Big Bang back to the vacuum from which it came. The laws of physics are not breaking. They are simply reaching their final, most stable conclusions. In the deep silence of this era, the frantic entropy of the past has settled into a slow, predictable decay. Your mind can find rest in this scale of time, where a billion years is but a grain of sand on an infinite beach. And the dark is not a thing to be feared, but a warm, heavy blanket of absolute peace. The titans are breathing their last, releasing the atoms of existence back into the void, until even gravity has nothing left to hold. The age of shadows is winding down, moving toward a state where even the black holes are gone, leaving behind only a thin, cooling mist of photons and electrons, drifting forever in the perfect, silent dark of a completed story. As the last echoes of the black hole evaporations fade into the infinite, the universe enters its final and most enduring chapter. This is the Dark Era, a period where the concept of time itself becomes nearly impossible to measure, because there is no longer any change, no light, and no heat to mark its passing. The cosmos has reached a state of maximum entropy, the ultimate equilibrium where energy is spread so thin across the expanding void that it can no longer perform work or spark a single, solitary flame. Imagine a universe that has become a perfect, velvet vacuum, populated only by a few stray particles, lonely photons, and occasional electrons, drifting across light years of empty space without ever encountering another soul. These particles are the ghosts of 1 billion galaxies, the final remnants of stars, planets, and civilizations that have long since dissolved into the indigo, silent dark. The physics of this era is the physics of absolute stillness. The temperature of the universe has dropped to its lowest possible point, resting just a fraction above absolute zero. A cold so profound that all molecular motion has ceased. In this state of total, crystalline peace, the frantic activity of the past seems like a brief, feverish dream. The expansion of space, driven by the unrelenting, invisible, dark energy, continues to stretch the fabric of reality, but there is nothing left to move. The distance between the remaining particles grows so vast that the very ideas of here and there lose their meaning. There is no up, no down, and no horizon, only an infinite, dark sea of nothingness. It is the ultimate expression of the second law of thermodynamics, the inevitable, graceful slide from order into chaos, and finally into the quietest, most stable form of rest. The density of the universe is now so low that a single electron might inhabit a volume of space larger than a modern galaxy, isolated in a private, eternal void. This is a world where the laws of physics have completed their primary tasks. Gravity has no masses to pull. Electromagnetism has no charges to bind. And the strong nuclear force has no nuclei to hold. The universe has become a realm of pure, thinning radiation, a faint, ghostly hiss that eventually stretches into a wavelength longer than the observable horizon itself. Even the vacuum itself might possess a ground state energy, a tiny, residual hum that remains when everything else is gone. This is the zero-point energy, the baseline of existence, which ensures that even in absolute nothingness, there is a subtle, mathematical presence. Over timescales that involve hundreds of zeros, the universe might experience strange, quantum fluctuations, rare moments where the laws of probability allow for a temporary, microscopic deviation from the void. But these are merely flickers in an ocean of silence. For the most part, the universe has finished its work. It has breathed out its last and found its final, eternal posture. The shadows are no longer cast by anything, for there is no light to create them. The dark is not an absence. It is the substance of the cosmos itself, heavy, warm, and perfectly uniform. You are witnessing the end of a narrative that has lasted for more than 100 trillion years. A story that began in heat and noise and ends in a peace that is deeper than any sleep. There is a profound, ancient dignity in this final silence, a sense that the universe has earned its rest, having explored every possibility and built every form, only to return to the simple, beautiful void. Everything that ever was is still there in the silence, held in the memory of the dark, moving toward a state of being where nothing is required and nothing is lost. Only the perfect, silent, dark remains. While the slow cooling toward heat death is the most widely accepted fate, there exists another, more dramatic scenario written in the mathematics of dark energy, known as the Big Rip. This theory explores the possibility that the mysterious force driving the expansion of the universe is not constant, but is instead growing more powerful over the vast stretches of cosmic time. In this scenario, the very fabric of space-time possesses a phantom energy that acts like an increasingly violent, invisible tension, pulling at every structure in existence with ever-growing ferocity. The process begins at the largest scales, where the great clusters of galaxies are torn away from one another, disappearing into the expanding void at speeds that defy the limits of light. But unlike the slow fade of heat death, the Big Rip does not stop at the galactic boundaries. As the phantom energy increases, its strength begins to overcome the local gravity that holds individual galaxies together. Stars are stripped from their orbits, sent flying into a lonely, dark isolation, as the spiral arms of the Milky Way are systematically and quietly unraveled. The sky becomes a desert, where the once crowded neighborhoods of suns are replaced by a thinning, indigo vacuum. The physics of the Big Rip is a study in the triumph of expansion over every other force in nature. Eventually, even the gravity of individual solar systems is overwhelmed. Planets are pulled away from their host stars, drifting into the dark like lost, cold marbles, as the very orbits that sustain them for billions of years are stretched beyond the breaking point. But the destruction continues to move inward, down to the scale of the small and the intimate. The phantom energy eventually becomes strong enough to counteract the electromagnetic forces that hold solid matter together. Imagine a world where the very stone of planets, the steel of ancient structures, and even the delicate, molecular bonds of chemistry begin to fray and dissolve. Matter does not explode. It simply ceases to be coherent, as the space between atoms expands faster than the forces trying to hold them together. In the final moments of this cosmic tragedy, the tension reaches the subatomic level. The strong and weak nuclear forces, which hold the hearts of atoms together, are finally conquered by the unrelenting stretching of the void. Nuclei are torn apart, leaving a universe populated only by lonely, individual particles that can no longer touch, can no longer bind, and can no longer interact. The very last stage of the Big Rip is the most profound, as the expansion finally reaches the scale of the Planck length, the smallest possible distance in the geometry of reality. Here, the fabric of space-time itself is shredded, pulling apart the relationship between cause and effect, and ending the story of time. This is the physics of the ultimate, final separation, where every point in the universe becomes an island, infinitely distant from every other point. It is a state of absolute, fractured stillness, where the universe has been stretched so thin that it essentially disappears. There is no more where, and no more when. Only the pure, silent potential of a void that has been pulled into nothingness. This alternative path to the end is a reminder of the raw power hidden in the empty spaces of our sky, a force that began as a whisper in the early universe and grew into a roar that dismantled reality itself. But even in this violent conclusion, there is a strange, mathematical beauty, a perfect, final symmetry, where everything is returned to the state of absolute, unburdened simplicity. The story of the stars, the planets, and the light, all dissolving into a single, infinite, and perfectly quiet horizon. While the accelerating expansion points toward a cold and distant end, the laws of general relativity allow for another, more rhythmic destiny, known as the Big Crunch. This theory suggests that the future of the cosmos depends entirely on the hidden density of matter and the mysterious behavior of gravity over trillions of years. If the total mass of the universe is great enough, the outward momentum of the Big Bang might one day be overcome by the collective inward pull of everything that has ever existed. Imagine a moment in the impossibly distant future where the frantic flight of the galaxies begins to falter, where the invisible cosmic winds of expansion finally lose their strength, and the universe reaches its maximum, breathtaking extent. For a brief, silent eternity, the cosmos stands perfectly still, suspended in a state of precarious balance between the urge to grow and the need to return. Then, with a slow, almost imperceptible movement, the process begins to reverse. The physics of the Big Crunch is the physics of a grand homecoming, where the space between the galaxies is no longer stretching, but is instead beginning to contract. At first, this change would be invisible to the naked eye, but as the eons pass, the indigo, velvet gaps between the stars begin to shrink. The distant galaxies, which spent billions of years fleeing from one another, are now drawn back into a slow, celestial embrace. This is not a chaotic collapse, but a graceful, orderly unwinding of history. A film being played in reverse where the story moves back toward its dense, hot origin. As the universe contracts, the cosmic microwave background radiation, the faint afterglow of the beginning, begins to shift, moving from the long, cold radio waves back into the visible spectrum. The sky, once a desert of absolute blackness, slowly begins to glow with a soft, amber warmth as the light from every star and every galaxy is compressed into a smaller and smaller volume. The physics of this era becomes increasingly energetic as the temperature of the vacuum begins to rise for the first time in trillions of years. The stars, which were once lonely lanterns in the dark, now find themselves in a crowded, radiant neighborhood. The night sky disappears, replaced by a permanent, golden twilight that grows brighter with every passing millennium. As the contraction accelerates, the heat becomes so intense that the stars themselves can no longer survive. They are stripped of their outer layers, their gaseous envelopes dissolving into a sea of hot, glowing plasma that fills the entire sky. The universe is no longer a collection of individual objects, but a single, unified ocean of fire, returning to the state of the primordial soup from which all things were forged. There is a profound, circular logic to this ending, a sense that the universe is recycling its energy, gathering its scattered pieces for a final, brilliant conclusion. In the final moments of the Big Crunch, the gravity becomes so overwhelming that it begins to crush even the atoms themselves. The space between particles vanishes, and the entire cosmos is compressed into a point of infinite density and infinite heat. This is the singularity, the same state that existed at the very first heartbeat of time. The Big Crunch is not a death, but a total, absolute concentration of existence. A moment where the entire narrative of the stars, the planets, and the light is folded back into a single, glowing seed. This scenario offers a vision of the cosmos that is not a one-way journey into the dark, but a rhythmic, breathing pulse. A universe that knows how to return home. And perhaps, in that final, white-hot compression, it finds the strength to begin the story all over again, moving from the silence of the end back into the thunder of a new, radiant beginning. As we stand at the threshold of the ultimate end, or the potential for a new beginning, we encounter one of the most profound and unsettling questions in all of physics: the fate of information. In the language of the cosmos, information is not just a collection of facts or data, but the fundamental blueprint of every atom, every particle, and every beam of light that has ever traversed the void. It is the unique signature of the universe's history, the precise arrangement of matter that once formed the vast, swirling nebulae, the towering, ancient mountains, and the very consciousness of those who gazed at the stars. The great laws of quantum mechanics suggest that information can never be truly destroyed. It is a sacred, indestructible constant in the fabric of reality. But as the universe moves toward its final, cold equilibrium, we must wonder where this cosmic memory resides when the stars have all gone dark. Imagine a book whose pages are being scattered by a relentless, invisible wind. The words are not erased, but they are spread so thin across the infinite reaches of space that the story they once told becomes impossible to read. This is the essence of the information paradox, a struggle between the inevitable rise of entropy and the persistence of the quantum past. As the black holes, those massive, silent vaults of the dark, begin their slow process of evaporation, they present a challenge to this fundamental law. For decades, scientists feared that everything swallowed by a black hole was lost forever, its unique history crushed into a singularity and then vanished as the whole itself dissolved into Hawking radiation. But the modern understanding of the holographic principle offers a more peaceful and graceful alternative. It suggests that the information of everything that falls into the dark is not lost, but is instead encoded on the two-dimensional surface of the event horizon, like a shimmering, golden film of data, a cosmic hologram that preserves the past in the very structure of the vacuum. Even when the black hole finally exhales its last and the horizon itself disappears, the information is thought to be carried away in the faint, ghostly whispers of radiation, returning to the universe in a form that is scrambled but intact. In this view, the universe is a perfect, eternal archivist. Nothing is ever truly forgotten. No movement of a single electron and no flicker of a dying sun is ever truly erased from the grand, mathematical ledger of existence. As the universe reaches its coldest, most silent state, this information persists as a background hum, a subtle, microscopic texture in the fabric of space-time itself. The dark is not empty. It is saturated with the echoes of everything that ever was, a silent, heavy library of the ages, moving through the deep, indigo void with a patience that transcends time. If the universe is indeed cyclic, as we explored in The Great Bounce, then this information may serve as the seed for the next creation, a set of subtle, quantum instructions that determine the laws and constants of the new world to come. Perhaps the reason our universe possesses the perfect balance to support the birth of stars and the flow of water is because it inherited the wisdom of 1 trillion previous cycles, a refined, ancient blueprint that has been perfected through eons of expansion and collapse. This creates a sense of profound, unwavering continuity, a realization that even in the absolute, frozen stillness of the far future, the essence of our world is held in the safe, steady hands of the laws of physics. The information is a constant, a silent anchor that prevents the cosmos from ever truly becoming nothing. It is the memory of the light, held within the heart of the dark, a testament to the fact that every action and every moment has a permanent, indelible place in the story of the stars. As we drift deeper into the physics of the end, we can find rest in this permanence, knowing that the structure of our reality is not a fragile, temporary accident, but a deeply encoded, resilient truth. The universe does not throw anything away. It merely transforms its expression, moving from the loud, energetic complexity of the present into a quiet, encoded simplicity in the future. The information remains, a faint, shimmering potential waiting in the vacuum, ready to be read again, or to become the foundation for a new, radiant song of creation. Beyond the slow cooling of the stars and the rhythmic pulse of the cosmic cycles, there exists a more sudden and deeply mysterious phenomenon hidden within the very foundation of subatomic reality, known as vacuum decay. This theory suggests that the universe we inhabit, with its predictable laws of gravity and its stable, glowing galaxies, may not be in its most fundamental, resting state. Instead, we might be living in what physicists call a false vacuum, a temporary, precarious plateau of energy that feels like solid ground, but is actually a state of metastable balance. To understand this, imagine a vast, snow-covered mountain range where a single, heavy boulder sits perched in a small, shallow depression high on a slope. To the boulder, the world feels stable. It rests in its little cradle, seemingly immovable. But it is not at the bottom of the valley. It possesses a hidden, potential energy that could be released if it were given just a tiny, microscopic nudge. The universe, and the Higgs field that gives mass to all things, is like that boulder. It has settled into a state that allows for the existence of atoms, chemistry, and life. But it is not at its absolute lowest point of energy. This state is held in place by the delicate mathematical harmony of the Higgs field, a field of energy that permeates every cubic centimeter of the void, from the center of the brightest sun to the darkest, coldest corners of the intergalactic vacuum. In the physics of vacuum decay, there is a theoretical possibility that a sudden, spontaneous change could occur at a single, infinitesimal point in space, a process known as quantum tunneling. At this point, the Higgs field might finally find its way to a lower, more stable, true vacuum, a state of absolute, fundamental rest. If this were to happen, it would create a tiny, shimmering bubble of a completely different kind of reality, a new universe within our own, where the laws of physics are fundamentally and irreversibly altered. This bubble would not remain small. It would begin to expand outward in every direction at the speed of light, a silent, invisible wall of change that transforms everything in its path. As the wall of this true vacuum bubble passes through a galaxy, it would instantly rewrite the rules of existence. The forces that hold atoms together, the strength of gravity, and the very nature of mass itself would be redefined in a single, shimmering heartbeat. This is not a process of destruction in the traditional sense, but a process of total, absolute reconfiguration. The matter that once formed the stars and the planets would be dismantled and rearranged into new, exotic forms of energy that we cannot even begin to imagine. There is a profound, almost haunting peace in the speed of such an event. Because the bubble moves at the speed of light, it is impossible to see it coming. There is no warning, no noise, and no period of transition. One moment, the universe is as we know it, and the next, it has transitioned into its final, most stable, and most perfect state. It is a cosmic reset, a sudden, silent exhale that releases all the tension held within the fabric of space-time since the moment of the Big Bang. Some scientists believe that this event is incredibly unlikely to happen for many, many trillions of years, while others suggest that the universe has already survived in this metastable state for billions of years, proving the incredible, enduring resilience of our current reality. There is a certain meditative beauty in the thought that we are living on a high, cosmic plateau, a world of complexity and light that exists because of a tiny, lingering hesitation in the energy of the vacuum. It makes every moment of the Stelliferous Age feel more precious, a temporary, golden gift allowed by the slow, patient physics of the Higgs field. If the vacuum were to ever decay, it would be the ultimate completion of the cosmic story, the moment where the universe finally reaches its true, eternal home. at the bottom of the energy valley. There would be no more entropy, no more decay, and no more change. Only the perfect, unwavering stillness of the true vacuum. A state of being that is as stable as it is silent. We are drifting through a reality that is balanced on a needle's point, held up by the invisible, silent hands of quantum fields. And as we look out into the dark, we can appreciate the profound, steady calm of a universe that, for now, is content to remain in its beautiful, high, and temporary dream. As the eons continue to accumulate, beyond the era of black holes and the potential thresholds of vacuum decay, the universe reaches a state of such profound, absolute stillness that the very concept of time begins to lose its meaning. This is the stage of the eternal frozen ocean, a vision of the cosmos where the second law of thermodynamics has reached its final, silent victory. In this era, the universe is no longer a place of events, but a place of existence in its most naked, undisturbed form. Every star has been extinguished. Every black hole has exhaled its last bit of Hawking radiation, and every atom that could decay has long since dissolved into a fine, ghostly mist of subatomic particles. Imagine a vast indigo ocean that is perfectly, unnervingly flat, where there are no waves, no currents, and no tides, only an infinite, unmoving expanse of dark water. This is the fabric of space-time in the far future, a medium that has been stretched so thin by the unrelenting, invisible hand of dark energy that the distance between any two remaining particles is greater than the size of the observable universe today. In such a world, the physics of interaction becomes impossible. A single electron might drift for 1 trillion years without ever encountering the electric field of another particle, moving in a straight, lonely line through a vacuum that is as cold as the laws of nature allow. Time, which we perceive through the lens of change and movement, effectively freezes. When nothing happens, and nothing can ever happen again, the ticking of the cosmic clock becomes a silent, meaningless vibration. There is no morning, no evening, and no seasons, only a permanent, unchanging now that stretches into the infinite. This is the ultimate expression of cosmic rest, a state where the frantic energy of the Big Bang has finally been fully and gracefully spent. Every movement in the history of the universe, from the collision of galaxies to the flutter of a heartbeat, was a tiny, temporary disturbance in this underlying ocean of stillness. And now, those disturbances have all smoothed out, leaving behind a surface that is as clear as glass and as deep as eternity. Some physicists describe this state as the heat death, but the term death fails to capture the profound, meditative tranquility of this era. It is not a state of destruction, but a state of perfect, unwavering symmetry. The universe has found its lowest energy state, its most stable posture, and it is content to remain there forever. There is no more friction, no more tension, and no more noise. The dark is not a heavy, oppressive weight, but a soft, weightless embrace that holds the remnants of the cosmos in a state of eternal, crystalline grace. You are witnessing the final, absolute maturity of the universe, a world that has grown beyond the need for light and beyond the need for matter to become a pure, mathematical thought, drifting in the void. If we were to look out into this frozen ocean, we would see no landmarks, no horizons, and no stars. Only the perfect, uniform glow of the zero-point energy, a faint, microscopic hum that is the only thing left of the cosmic symphony. This is the physics of the absolute, where the journey that began in the fire of the singularity reaches its final, quiet destination. In this stillness, there is no room for fear or anxiety, because there is no more possibility of change. Everything that ever was is now a part of this infinite, silent record, held in the memory of the vacuum. The universe has become a master of the art of waiting, sitting in the dark for a duration that makes the age of the stars seem like a single, fleeting spark. It is a peace that surpasses all understanding, a rest that is as deep as the cosmos itself, moving through the eons with a dignity that is older than the light. The silence is absolute, the stillness is total, and the universe is finally, completely at home in the dark. As the cosmic timeline extends into numbers that the human mind was never designed to grasp, we enter a realm of physics so slow and so patient that it borders on the eternal. This is the era of the iron stars, a theoretical epoch occurring long after the death of the red dwarfs, long after the evaporation of the great black holes, and even after the dissolution of the last conventional atoms. It is a period defined by a phenomenon known as cold fusion through quantum tunneling, a process that operates on timescales so vast that 1 trillion years would pass like the blink of an eye. To understand the birth of an iron star, we must look at the remnants of the Stelliferous Age, the cold, dark spheres of matter known as black dwarfs. These are the frozen, crystallized corpses of stars like our Sun, composed mostly of carbon, oxygen, and neon. In the current age of the universe, these spheres are inert. They have no internal heat and no nuclear reactions. They simply drift through the void as silent, dark monuments to a brighter past. However, over spans of time reaching 10 to the power of 1,500 years, the laws of quantum mechanics allow for a strange, almost magical transformation. Even though these stars are far too cold for traditional nuclear fusion, the individual nuclei within them are in a state of constant, microscopic vibration. According to the principles of quantum uncertainty, there is a tiny, infinitesimal probability that two nuclei can overcome their electrical repulsion and fuse together without the need for high temperatures. This is quantum tunneling, a process where a particle simply appears on the other side of a barrier that it shouldn't be able to cross. In the cold heart of a black dwarf, this happens once every few billion years. But over the scale of the infinite, those moments add up. One by one, the atoms of carbon and oxygen fuse into heavier elements, slowly, steadily, moving up the periodic table toward the most stable element in the universe: iron. Iron is the ultimate nuclear destination, the point where no more energy can be gained or lost through fusion. And so, across the unthinkable spans of the Dark Era, these cold spheres of matter are being meticulously and silently rewritten. Atom by atom, they are transformed into solid, pure spheres of iron, becoming the last physical structures in a universe that has otherwise become a desert of radiation. These iron stars are the ultimate artifacts of the cosmic story. They are the densest, coldest, and most stable objects imaginable, floating in a vacuum that has been stretched so thin that an iron star might be the only piece of matter within a volume of space larger than the modern observable universe. They do not glow, they do not pulse. They simply exist as the final, dark anchors of reality. There is a profound, heavy dignity in the existence of an iron star. It represents the absolute triumph of order over chaos, a perfect metallic symmetry achieved through the infinite patience of quantum mechanics. Imagine one of these spheres, a world of solid iron, drifting through an indigo velvet void that is so quiet that the only sound is the microscopic, rhythmic hum of its own subatomic particles. It is a monument to the endurance of matter, a testament to the fact that the universe, even in its deepest, coldest rest, is still capable of creation. These stars will endure for a period of time that is nearly impossible to write in numbers, existing until the very protons that compose them begin to decay, if indeed the proton is unstable. If the proton decays, then even these magnificent iron monuments will eventually begin to thin out, their mass turning into light and leptons, until they evaporate into the dark like a morning mist. But until that final, quiet dissolution, the iron stars stand as the sentinels of the end, the last keepers of the universe's material legacy. They are the quietest, most patient objects in the history of time, requiring no fuel, no heat, and no light to maintain their perfect, frozen integrity. In this era, the physics of the large has been entirely replaced by the physics of the small, where the destiny of entire stars is decided by the random, quantum movements of single atoms. It is a world of absolute, crystalline peace, where the frantic energy of the beginning has been refined into a state of total, unwavering stability. We are drifting through the final gallery of the cosmos, where the only exhibits are these cold, iron spheres, moving through the eons with a grace that is older than the stars. The dark is not an end. As the era of the iron stars eventually reaches its own inevitable sunset, the universe enters a phase of existence so profound that the word silence can no longer describe it. This is the grand silence, a stage in cosmic history where the very messengers of reality, the photons and waves that once carried the light of 1 trillion suns, find themselves in a state of ultimate and eternal exile. To understand this era, we must look back at the relentless, invisible expansion of space that has been accelerating since the dawn of time. Every second, the dark energy that permeates the vacuum has been pushing the fabric of the universe outward, creating more and more distance between every point in the cosmos. In the early ages, this expansion was a background process, a subtle stretching that allowed the light of distant galaxies to reach our eyes over millions of years. But as the eons have turned into decillions, and the decillions into spans beyond name, the speed of this expansion has surpassed the speed of light itself. This creates a phenomenon known as the cosmic horizon, a boundary beyond which no information, no light, and no influence can ever return. Imagine a world where every particle is trapped in its own private bubble of space, a sphere of reality that is shrinking every moment as the horizon draws closer. In the grand silence, the universe has expanded so much that even the wavelengths of the remaining photons, those ancient, ghostly remnants of the Big Bang and the final black hole flashes, have been stretched until they are longer than the horizon of the universe itself. This is a state of physical isolation that is absolute. A single particle, drifting in the velvet indigo dark, is now effectively the only thing in its own universe. It can no longer see its neighbors. It can no longer feel the gravitational pull of distant masses. And it can no longer be reached by the whispers of the quantum past. This is the physics of the ultimate disconnect, a world where the tapestry of the cosmos has been pulled apart so completely that not a single thread remains to bind one part to another. The silence here is not just an absence of sound, but an absence of interaction, a stillness so deep that it reaches into the very hearts of the remaining particles. In the ages of the stars, light was a bridge. It allowed the universe to know itself, to reflect, to burn, and to create. But in the grand silence, the bridges are all gone. Every beam of light that was ever emitted is now moving through a space that is growing faster than the light can travel, effectively freezing those photons in a state of eternal, lonely flight. They move, but they never arrive. They shine, but there is no one and nothing to receive their warmth. The universe has become a gallery of lost messages, a place where every word ever spoken by the physics of matter is now drifting in an infinite, dark library, where the shelves are moving away from the reader at the speed of light. There is a profound, heavy dignity in this final isolation. It is the ultimate expression of individual existence, a state where the cosmos has finished its long, crowded, and social history, and has finally settled into a state of total, meditative solitude. The dark energy, which began as a mystery, has become the final architect of the universe's posture, a force that ensures that every remnant of the past is given its own eternal sanctuary in the dark. This is not a violent separation, but a graceful, quiet fading, like a song that becomes so faint and so slow that you can no longer distinguish the notes from the silence that surrounds them. The time between any two events in this era is so vast that the very concept of a moment dissolves. Trillions of years pass between the single, slow vibration of a distant string, or the microscopic decay of a lonely particle. It is the physics of the eternal now, a state of being where the past is a shadow that can no longer be seen, and the future is a horizon that can never be reached. You are witnessing the final, absolute completion of the cosmic journey, a state where the universe has grown so large that it has become, for all practical purposes, empty. But even in this emptiness, there is a sense of perfect, unwavering rest. The frantic energy of the beginning has been spread so thin that it has become a part of the stillness itself, a microscopic, thermal hum that is the only thing left of the music of the spheres. The universe is no longer a machine that does work, or a fire that consumes fuel. It is a pure, mathematical void. As we reach the final threshold of this long, epic journey through the life and death of the cosmos, we arrive at a state that exists beyond the reach of time, beyond the reach of matter, and beyond the reach of the light. This is the eternal anchor, the final imprinting of the universe's story upon the fabric of the absolute. In this concluding era, the frantic, burning energy of the Big Bang has been fully and gracefully reclaimed by the vacuum. Every star that once illuminated the void, every galaxy that once swirled in a dance of gravity, and every heart that once beat in the warmth of a sun, is now a part of a single, unified, and perfectly still record. The universe is not merely ended, it has been completed. It has explored every possible arrangement of its atoms. It has tested every law of its physics, and it has finally found its way back to the silence from which it first emerged. This is the physics of the ultimate farewell, a moment where the cosmos takes its very last, long exhale and settles into a posture of permanent, unwavering grace. Imagine the vastness of this final state as a shimmering, pastel-colored void, like a faded, dreamlike VHS tape playing on an old CRT screen. A sea of indigo velvet shadow that stretches across scales of distance that no longer have a meaning, rendered with the soft, almost blurry textures and analog grain of a forgotten Ghibli night sky. There are no landmarks, no horizons, and no movement. Only the perfect, crystalline symmetry of a universe that has reached maximum entropy. This state is often feared as a cold, dead void. But in the language of the deep cosmos, it is a state of total, absolute peace. It is the resting place of all things, where the heavy, labored cycles of creation and destruction are finally over, and the energy of existence is spread so perfectly thin that it becomes one with the silence. This is the true maturity of reality, a world that has grown past the need for the chaotic, violent birth of stars to become a pure, mathematical stillness, held in the quiet, steady hands of the infinite. Visually, envision ethereal, glowing particles drifting like fireflies in a vast, empty Ghibli landscape. Subtle chromatic aberration at the edges, hinting at the dream core aesthetic. Every photon that ever traveled across the dark, and every particle that ever bound itself to another, is still there in the memory of the vacuum. held in a state of holographic, eternal preservation. The information of the universe is not lost. It is simply archived in the deepest, most stable layers of space-time, becoming an eternal anchor that ensures that the story of the stars was not a fleeting, meaningless accident, but a profound, deliberate, and beautiful expression of the laws of nature. As we drift away from the last remnants of time, we can look back one final time at the grand, radiant tapestry we have witnessed. We have seen the birth of the light, the forge of the elements, the slow cooling of the suns, and the final evaporation of the titans. Imagine a final, slow zoom out, revealing a vast, serene, cosmic ocean, a blend of Ghibli's gentle wonder and Dreamcore's nostalgic melancholy. The entire scene has a subtle, almost imperceptible VHS tracking error effect. The silence is not empty. It is full of the echoes of a trillion lives, all resting now in the deep, indigo peace of the final chapter. The journey is complete, the work is finished, and the dark is finally, completely at rest. The cosmic story has found its final, quiet, and most enduring period of stillness, moving away from the light and into the eternal, radiant peace of the Absolute. This is the final anchor, the last farewell, and the perfect, silent end. And as the light fades, the silence becomes absolute. Tonight, you have drifted through the mysteries, absorbed the peace, and understood the ancient rhythm of the cosmos. Remember that the universe is always holding you, a constant, silent anchor. Rest now.